Properties of logarithms. Let a be a positive real number not equal to 1. Let x and y be positive real numbers, and let r be any real number. Property 1. Log base a of x times y equals log base a of x plus log base a of y. This is read, the log of a product is the sum of the logs. Property 2. Log base a of x divided by y equals log base a of x minus log base a of y. The log of the quotient is the difference of the logs. Property 3. Log base a of x to the r equals r times log base a of x. The log of something raised to a power is the power times the log. We will use these properties of logarithms to compress or expand logarithms. This table demonstrates the correct statement versus some often incorrect statements. Alright, so let's go ahead and take a look at an example. We are expanding logarithms using the properties from above. So I see log base 4 of the product of 64 times x to the third times the square root of x. So since I have a product, I know that I'm going to write the sum of logs. So let's go ahead and expand that. That would be log base 4 of 64x to the third square root of y. That equals log base 4 of 64 plus log base 4 of x to the third plus log base 4 of the square root of y. Now I can also expand this further by rewriting log base 4 of 64 as 4 to the third power and rewriting log base 4 of the square root of y as y to the 1/2 power. Log base 4 of 4 to the third, using the property from the previous section, log base a of a to the x is equal to x. This turns into a 3. And then use the power rule to bring down the 3 in front of log base 4 of x. And again use the power rule to bring down the 1/2. And that gives me 1/2 log base 4 of y. Alright, in this next example I have the third root of a quotient, a product, and some powers. So let's go ahead and expand this. Log base a. I'm going to go ahead and write this xy squared over z to the 4th to the 1/3 power. Get rid of that cube root. And I'm going to start by using my power rule. And then my quotient rule. And then I see I have a product. And then I can power down. And one more step is possible but not necessary. You can distribute the 1/3 to everything inside the parentheses, but that's not a necessary rule, but it does hold true. And there would be your final answer. Alright, now let's go the other direction. Let's condense logarithms. So we want to condense this as much as possible, and I do see that I have a power rule. So this 2 is going to go up into the power. And then I have the difference of logs, so that's a quotient. And then we can clean that up by using what we know about division, and that's reciprocate and multiply. So that gives us log base 3 of x squared y over 9. Alright, so the next one I've got a quotient and a sum, and also a power rule. So I'm going to power up on y. So ln of x squared minus ln of y to the 1/2 plus ln of 2. So this would be ln of x squared over y to the 1/2 plus ln of 2. And that would be ln of x squared over y to the 1/2 times 2 so that would be 2x ln of 2x squared over, and y to the 1/2 I'm going to write that as the square root of y. Okay, next example, I have a sum, so product log base b of 5 I have a exponent rule, so that'd be log base b of 5 plus log base b of x to the negative 2, power to a power, you multiply the powers, and then product rule, log base b of 5x to the negative 2, and then get rid of your negative exponent just to clean it up, log base b of 5 over x squared. Alright, the last part of this section is the change of base formula, and this formula is not something that is used frequently anymore because of the advancement of calculators, but I still teach it in this class because I use it in my calculus classes. And basically what the change of base formula does is change a logarithm from one base to another using this formula. So log base b of x is equal to log of any base of x over log of that same base over of b. More commonly, we can convert that to log base 10 of x over log base 10 of b, or the natural log of x over the natural log of b. And that's pretty much your preference. Both of these are keys on your calculator, so you can get a decimal approximation, which is what we will do in our examples. So they want to evaluate log base 7 of 15. Now many of your calculators do non-common base logarithms, so you can just type that in your calculator. But if you have a more basic calculator, you'll need to use a change of base. So for this one, I'm going to use the natural log. So that's the ln of 15 divided by ln of 7. And use your calculator to give you an approximation. So I'm going to use our Desmos calculator. So that would be ln of 15 over ln of 7. So that would be approximately 1.39. Okay, let's do one more of these. And for this one I'm going to use common log. So this would be log base 10 of 3 over log base 10 of 1/2. And that's going to give us negative 1.58, and it's an approximation.